What if a single error in your DNA could decide whether you are able to feel the world at all? For 6 generations, that question has haunted one family in Pennsylvania. Their name is Deater. And for 140 years, a mutation they've carried has quietly been erasing sensation, nerve by nerve, until touch, and pain, and temperature completely disappear. It doesn't strike at birth. It waits. And by the time it reveals itself, the next generation has already received it. Welcome to Gothic Ledger. Tonight, we open the bloodline record of the Deater family. A true story where fate and science intertwine. A family whose tragedy became a cornerstone for modern medicine. A curse written not in superstition, but in a single genetic letter. Before we begin, take a moment and write in the comments where you're watching from and what time it is right now. I always want to know who's awake with us when the past comes alive. And if you value stories that uncover the dark, forgotten edges of history, like this video and subscribe our channel so you never miss what waits beneath the archives. Because tonight's story isn't about what they lost, it's about what they gave back to science. She is 22, standing barefoot on the floor of her Bear Creek, Pennsylvania apartment, when she realizes the tile beneath her toes is something she cannot feel. The numbness is faint, almost ignorable, but familiar. Her father had warned her that this is how it begins, a tingling that pretends to be nothing at all. By the end of the week, the sensation has reached her arches. She presses her feet harder against the floor as though pressure could return what is leaving. It doesn't. She tries walking longer, running more, convincing herself that circulation will fix it. It doesn't. She knows this pattern. Every Deater learns it before adulthood. For generations, the family has lived in this region. Farmers, teachers, nurses, ordinary lives with one extraordinary inheritance. Some reach 30 before it starts. Some never notice until burns appear on skin they cannot feel. For others, the warning comes early. She knows which group she belongs to now. Doctors call it hereditary sensory neuropathy, a condition that from the outside silences the body's nerves. The explanation is technical, but its legacy is not. It is carved through family trees, marked beside names on obituaries and birth certificates. Half of them carry it, half are spared. None can predict which half they will belong to until the signs emerge. Her grandfather used to keep a notebook of symptoms across the family. The handwriting changes over decades. Each entry another descendant recording the same steady decline, the same loss of touch. There are no surprises in its progression. The only question is when it will choose to begin. The pattern has lasted 140 years. No curse, no contagion, just a dominant mutation. One misplaced letter in a gene passed from parent to child like an inheritance no one can refuse. Every child of an affected parent faces the same odds. 1 in 2. A coin flip disguised as a lineage. Shirhan has heard the odds since childhood. The family never hides it. Medical students visit each year, asking questions, collecting samples, tracing the gene through time. The Deaters answer them all. They live as both family and Deater. Their bloodline has become a study that never ends. Tonight, she scrolls through archived family photographs. Generations of faces that look like her own. Some smiling, some sitting in wheelchairs, some standing beside hospital beds. It is not fear she feels now, but recognition. What started as an ache in her toes is simply the next entry in a story written long before her birth. Somewhere a geneticist will one day mark her as affected. A line will join her name to Alvin W. Deater, the first documented carrier born in 1884. The thread runs unbroken from him to her, binding each generation through the same unseen mechanism. An inheritance that hides until it's too late to change it. Every generation, the bloodline chooses. Half will carry it. Half will be spared, but no one escapes the waiting. On November 8, 1884, Alvin W. Deater was born in Bear Creek, Pennsylvania to Thomas Deater and Henrietta Anthony. The family owned a modest parcel of land, lived by the seasons, and left few written records. But within Alvin's cells, a single genetic error waited, an invisible thread that would define generations. At the time, no one could have recognized it. The language of heredity was still primitive. Mendel's papers on inheritance, published 2 decades earlier, were largely forgotten. Disease was seen as providence, not sequence. To the dieters, the notion that a condition could lie dormant through childhood and awaken years later was unimaginable. Alvin grew into a healthy man by all accounts. He married Lydia Ellen Wilson and started a large family, 12 children born between 1906 and 1924. For decades, they were an ordinary household in Luzerne County, but the pattern that would later bear their name had already been set. Of those 12 children, 7 would inherit what modern science now recognizes as a mutation in the SPTLC1 gene. The mutation follows a dominant inheritance. There are no hidden carriers. To possess the gene is to eventually express it. Each child of an affected parent faces a 50% chance of inheriting the same defect, a biological coin toss repeated endlessly down a bloodline. For Alvin's descendants, this probability would define every generation that followed. The condition destroys peripheral nerves from within. It begins at the edges, hands, feet, lower limbs, and moves inward with time. Yet its true cruelty lies not in its progression, but in its timing. Symptoms do not appear until adolescence or early adulthood, long after most have married and begun families of their own. By the time one realizes they carry it, the next generation is already born. Alvin lived without any known symptoms during his lifetime. There were no formal medical investigations while he was alive. No suspicion of an inherited disorder. The earliest signs appeared among his children in the 1920s. Numbness, weakness, unexplained injuries that refused to heal. Local physicians had no frame of reference. The cause was invisible and so it spread unnoticed. After Alvin's death on October 25, 1952, his descendants began to piece together what he could not have known. Medical researchers eventually identified the Deater family as one of the most thoroughly documented hereditary neuropathy lineages in the world. But in 1884, it was simply a birth like any other. No warning, no record, no reason to believe the family name would one day become a clinical term. He was not the first to carry the mutation. The defect predates him by generations, perhaps centuries, moving silently through unnamed ancestors whose symptoms were dismissed or forgotten. Alvin Deater's only distinction is that his descendants lived long enough and recorded enough for science to finally take notice. He was not the first, but he was the first they could trace. By 1906, Alvin Deater had built a life that appeared steady and secure. He married Lydia Ellen Wilson and opened a butcher shop on Market Street in Knox Township. The work demanded precision, balance, and endurance. He delivered cuts by hand, carried heavy carcasses, and sharpened blades each morning. His hands were strong, his feet were steady. Nothing about him suggested a flaw written deep within his genes. His 12 children were born across 2 decades, each arriving healthy and developing normally. They ran, worked, and played without restriction. The family's name appeared only in school rosters, church ledgers, and tax rolls, not in medical records. To the outside world, the Deaters were indistinguishable from their neighbors. This appearance of normalcy was not illusion. It was latency. The hereditary sensory neuropathy they carried does not appear at birth. It remains silent through childhood, masked by years of growth and vitality. The mutation's mechanism, one altered instruction in the SPTLC1 gene, does its damage slowly. Nerve fibers die cell by cell, but symptoms only emerge when enough have been lost to break communication between brain and body. Most carriers reach their late teens or early 20s before noticing anything unusual. It begins with subtle numbness, minor burns, or a stumble that doesn't hurt but should. By then, most have started work, marriage, or parenthood. The gene reveals itself only after it has already been passed forward. In Alvin's generation, there was no concept of delayed genetic expression. Medicine treated each symptom as isolated, an injury, a circulation problem, or exhaustion from manual labor. There were no specialized tests, no neurological frameworks. Without visible illness, no one would have considered heredity at all. Alvin's shop prospered. He became known for reliability and steady craft. But the records that survive, tax receipts, census data, family correspondence, hint that by his 40s he began delegating physical tasks to his older sons. Whether this was ordinary aging or the earliest trace of nerve loss remains uncertain. No clinical notes exist from that period. What is known is that by the next generation, the pattern had become undeniable. The Deater family's legacy would later form one of the longest continuous medical lineages in American history. Yet in these years there was nothing to mark them as subjects of study. They were a working family in rural Pennsylvania, unaware that within their DNA a sequence was preparing to manifest. The mutation waited unseen while children grew into adults when their own sons and daughters began showing signs. Decades later, doctors would trace it backward to these quiet years, to a time when the disease was already alive but undetected. The silence was not mercy. It was incubation. The curse does not announce itself at birth. It waits until you have already built a life. By the early 1920s, Alvin's children had reached adulthood. Most were working, married, or raising families of their own. Then one by one they began to notice something they couldn't explain. It started as numbness in the soles of their feet. A dull sensation that turned every surface into wood. At first they dismissed it as fatigue or poor shoes. But the feeling did not return. It spread upward. Within months, several siblings reported the same thing. Their legs felt distant. Hands lost grip. One child burned a finger on a stove and didn't notice until the skin changed color. Another stepped on a nail and kept walking, leaving no sign of pain. What began as an inconvenience soon became a quiet danger, the loss of pain itself. The condition was progressive but slow. Over years, the loss of touch expanded. Heat and cold became indistinguishable. Cuts healed poorly. Balance began to falter. Yet strength remained. The muscles worked. But the messages between brain and body were disrupted. Doctors had no explanation. In early 20th century Pennsylvania, hereditary sensory neuropathy was not a recognized concept. The family heard words like circulatory problem, rheumatism, or nerve exhaustion. None were accurate. The siblings compared symptoms privately. They noticed the same numbness appearing at the same ages, late teens to early 20s. The timing was consistent across generations to come. Each began life healthy, built careers, married, and had children before the first signs emerged. Only afterward did the pattern reveal itself. Rural medicine of the 1910s and 1920s offered little more than observation. Without antibiotics, X-rays, or nerve conduction studies, physicians could only record what they saw. In the Deater household, injuries were common. Burns, infections, and fractures appeared without pain to announce them. It was a paradoxical inheritance, the absence of suffering became a source of harm. The siblings learned to compensate. They watched their feet for injuries. They wore gloves to protect hands that could no longer sense temperature. What they didn't yet understand was that the cause lay far deeper in every cell that carried Alvin's DNA. The defect was invisible, chemical, and absolute. Once activated, it did not reverse. Word of their shared condition spread quietly through the family, never beyond it. There were no specialists to consult, no laboratories to analyze samples. For the Deaters, the problem remained confined to household memory. The knowledge passed verbally, a warning for the next generation to be careful of what they could no longer feel. By mid-century, researchers would label what happened here sensory neuropathy. But in those years, it was only a family secret carried by 7 siblings whose bodies betrayed them in identical ways. 7 of his 12 children inherited more than his name. They inherited their nerves' slow betrayal. By the mid-1920s, the pattern could no longer be ignored. Across the Deater household, physical changes began to mark those who had inherited the mutation. Fingers twisted at the joints, hands stiffened, and arches of the feet collapsed under unrecognized injury. What had begun as numbness now reshaped the body itself. Years of unnoticed burns, fractures, and infections left behind deformities that no physician could explain. Without pain to guide them, family members continued their routines, cutting, lifting, walking, unaware of the small injuries accumulating daily. Bones healed at wrong angles, scar tissue built where sensation should have stopped them. Slowly, the structure of hands and feet distorted. Photographs from this period, though few, reveal the change. Some show bandaged fingers, others hands curled inward as if frozen in mid-motion. Several of Alvin's children developed open wounds that refused to close. Circulation was normal. Awareness was not. When the body cannot feel, it cannot protect itself. Doctors from nearby towns began visiting out of curiosity. They recorded symptoms in brief notes. Chronic ulceration, joint deformity, familial tendency. None recognized the underlying cause. The vocabulary of genetics had not yet entered medicine, and peripheral nerve disease remained undefined. The Deater pattern became a topic of quiet discussion at medical meetings across Pennsylvania, known informally as the Deater condition. One physician suggested infection. Another blamed diet. A few suspected leprosy, though tests were negative. Every explanation failed because the mechanism was hidden in biochemistry, not bacteria. The mutation altered a single enzyme, changing how nerve cells processed lipids. Over years, toxic byproducts accumulated, dissolving the communication between tissue and brain. The damage presented as deformity, but its origin was microscopic. By the late 1930s, several family members used canes or braces. A few required amputations after repeated injuries became infected. Still, the family continued their lives, working, raising children, adapting to what they called the trouble in the feet. To them, it was hereditary misfortune. To science, it would become a foundation for understanding how genes could destroy the nervous system. The Deater name began appearing in early medical correspondence. Researchers noted the size of the family, the consistency of symptoms, and the pattern across generations. They had found something unique, a living lineage through which the progress of a genetic condition could be traced in real time. The transformation from symptom to symbol was complete. What began as invisible numbness was now visible in every movement, every hand extended in greeting, every step taken with caution. Their hands told a story their mouths could not explain. Something was destroying them from within. In 1922, a British physician named Dr. E. P. Hicks published a paper describing a peculiar hereditary condition in an English family. The symptoms mirrored those seen in the dieters: progressive loss of sensation, gnarled hands, and unexplained injuries. Hicks noted its familial pattern, but could not explain its cause. His report marked one of the earliest written records of hereditary sensory neuropathy. Though he had never heard of the Deaters, his findings confirmed that this mystery extended beyond one household, beyond one continent. 17 years later in 1939, the Deater name formally entered medical literature. Drive S. Tokentines and Dr. H. Ryman, physicians at the Temple University School of Medicine in Philadelphia, investigated reports of multiple family members across generations sharing identical nerve symptoms. Their observations became the first official medical documentation of what they termed a hereditary sensory radicular neuropathy. The researchers interviewed several Deater descendants and performed neurological examinations using the limited methods of the time. Reflex hammers, pin pricks, tuning forks. They found consistent results. Profound loss of pain and temperature sensation in the extremities, while muscle strength and intellect remained intact. The pattern pointed unmistakably to heredity. Tines and Ryman traced 3 full generations. Their diagram showed the condition appearing in roughly half of all offspring, a pattern that matched a dominant inheritance model. The implications were chilling. If one parent carried the mutation, each child faced a 50% chance of inheriting it. The numbers matched the data's own lived reality. Their paper published in the American Journal of Pathology attracted quiet interest from neurologists worldwide. At a time when genetics was still a young science, the data case became a chore for understanding how nerve disorders could follow predictable lines of inheritance. Medical students began studying the diagrams as examples of familial transmission of neuropathy. For the data family, the findings offered no relief. There was still no treatment, no prevention, and no explanation for the molecular cause. But for the first time, their condition had witnesses in the scientific world. People who wrote, diagrammed, and classified what generations had only endured. The family's name now appeared in journals, indexes, and conference proceedings. They had become both subjects and symbols. Ordinary people transformed into the foundation of a medical case study that would span the century. The data's personal history was no longer confined to memory or rumor. It was now preserved in medical archives. The disease had crossed a threshold. From private inheritance to public documentation, the silence of generations was replaced by print, citation, and research. For the first time, someone was writing down what the family had known for decades. The curse had a record. By 1951, decades of quiet documentation had built toward recognition. That year, Dr. Derek Denny Brown, a neurologist at Harvard Medical School, gathered years of case studies on unexplained hereditary nerve disorders. His analysis unified them under a single term: hereditary sensory radicular neuropathy. For the first time, the data family's condition had a scientific identity. Denny Brown's classification described a disorder of the peripheral nerves inherited through generations that caused progressive loss of sensation while sparing muscle strength. His terminology replaced guesswork with precision. Radicular referred to the nerve roots, neuropathy to their gradual destruction. It was the first attempt to define in language what had until then been invisible in biology. The publication drew attention from clinicians who had seen similar families but lacked a framework to describe them. The data's case was referenced as one of the most complete multigenerational examples known. Their lineage became the benchmark against which other hereditary neuropathies were compared. A decade later, the second generation of researchers began expanding the record. Dr. Henry Ryman, joined by Dr. McKinnon and Dr. Stanis Savic, conducted follow-up investigations that culminated in a landmark 1968 study. This time they could trace 4 generations of the data family, each showing identical progression and age of onset. The results confirmed what the family had long observed: a dominant inheritance pattern. In dominant inheritance, there are no silent carriers. One altered copy of the gene guarantees the condition's expression. Each child of an affected parent has a 50% probability of inheriting the mutation and certainty that if inherited it will manifest. The data showed perfect consistency. Every generation produced approximately half of its members with the condition, never skipping a single line. For medical science, this provided a rare natural experiment. The data family, now numbering over 70 individuals across several states, represented one of the clearest examples of hereditary transmission in neurology. For the family, it meant understanding what had once been chaos. The randomness they once feared was replaced by mathematics, an exact, indifferent ratio written in their DNA. By the late 1960s, medical journals referenced the data kindred as a cornerstone in hereditary neuropathy research. They had entered the global medical record. Their names, once spoken only in local clinics and family gatherings, appeared in textbooks, lectures, and teaching slides for neurology students worldwide. But naming it did not end it. Diagnosis did not bring treatment. The science could now describe the pattern, trace it, and label it. But it could not stop the process itself. The nerve damage continued as predictably as ever, documented now, but no less inevitable. The condition had evolved from mystery to knowledge. The knowledge carried no cure, only clarity. A name does not cure, but it transforms mystery into science. By the time medical records began to accumulate in the 1950s and 1960s, physicians could finally describe what the Deater family had lived for generations. The condition was not random, nor did it strike in isolation. It followed a strict timeline, 3 phases that unfolded with clinical precision. Phase 1 began in late adolescence or early adulthood. The first sign was sensory loss in the feet and hands. Touch faded, followed by temperature recognition. The affected could walk across sharp gravel or rest a hand on a stove without realizing injury. Reflexes diminished. Balance wavered and wounds appeared without warning. For most, this stage lasted several years. It marked the silent invasion, the slow withdrawal of sensation that made daily life deceptively hazardous. Phase 2 emerged in the 20s or 30s. Ironically, it brought pain back, but not the normal kind. Physicians described lancinating episodes, sudden electric pain radiating through the legs and arms. These spasms alternated with areas of total numbness, as if the nerves alternated between chaos and silence. Muscle weakness joined the pattern. Foot arches collapsed. Toes and fingers curved inward as structural control eroded. Deformities became visible. Patients began to require orthopedic support or assisted devices. During this phase, the contradiction was striking. An absence of protective pain combined with bursts of excruciating nerve firing. Medical observers called it paradoxical suffering. The nervous system breaking down while still trying to signal distress. No medication fully suppressed it. The pattern recurred with each generation that reached this age. Phase 3 defined the advanced stage. Decades of unnoticed trauma and nerve failure culminated in chronic tissue damage. Bones weakened under constant pressure and poor healing. Radiographs from Deater family studies in the 1960s showed structural collapse in feet and ankles. Some developed spontaneous fractures, breaks without impact because the skeletal system had lost the feedback loops that prevent overuse. Surgical intervention became common. Physicians performed amputations and joint stabilizations to prevent infection or mobility loss. These were not the result of external violence, but of the body's internal disconnection. The hands and feet bore the legacy of every signal the nerves failed to send. The progression was predictable and irreversible. Once the first phase began, the sequence never paused. No remission, no plateau. Each year brought further decline. Though cognition and internal organs remained untouched, it was a disease that dismantled the outer boundaries of the body while leaving the mind fully aware of the process. Across generations, this 3-phase pattern repeated with mathematical precision. The mutation determined the schedule. Medicine merely recorded it. The mutation does not strike once. It unfolds in stages, each more devastating than the last. By the 1970s, the Deater family had lived with hereditary sensory neuropathy for nearly a century. Diagnosis had given the condition a name, but not a solution. So, the family made a decision that few could make. They offered themselves to science. That decade, several Deater family members traveled from Pennsylvania to the National Institutes of Health in Bethesda, Maryland. It was not a single trip, but a series of coordinated visits involving multiple generations. Parents, children, and grandchildren all arrived to contribute blood, tissue, and history. For the first time, scientists could study a hereditary condition, not only across time, but within one living lineage. At the NIH, they underwent comprehensive neurological testing. Blood samples were drawn for biochemical studies. Nerve biopsies were performed to examine the microscopic damage invisible to the naked eye. Researchers recorded reflex responses, temperature thresholds, and sensation mapping. The process was invasive, meticulous, and often exhausting. Yet, the Deaters volunteered willingly. Their cooperation transformed the family from passive patients into active research partners. They were no longer only the subjects of case reports. They were collaborators in the search for understanding. Physicians described them as one of the most cooperative and complete hereditary study groups ever assembled. Their medical record stretching back to Alvin Data's generation provided a living history unmatched in neurology. For scientists, the Data family offered something invaluable: continuity. The same genetic mutation could now be examined across 90 years of progression within individuals of different ages and stages. This allowed researchers to track how the condition evolved not just within a person but across bloodlines. Each examination, each sample became a piece of a timeline stretching from the 1880s to the modern age. The family understood that none of this would help them directly. There was no treatment yet, only data collection, only observation. But they also knew that knowledge had to start somewhere. If their blood held the key to understanding, they were willing to let it be studied. They began to see their participation as a form of inheritance, too. Passing down not only a gene, but also the means to decode it. By the late 1970s, the NIH archives contained thousands of data points tied to the data name. The mutation that had once destroyed silently was now under the microscope, its pathways charted, and its consequences measured. The data's contribution became foundational to the next phase of research. The molecular search for the gene itself. It was not surrender. It was strategy. They could not cure themselves, but they could offer themselves to those who might. In 1986, a new phase of the data story began, not in Bear Creek, but in Boston. At Massachusetts General Hospital's Seelby Day Neuromuscular Research Laboratory, Dr. Robert H. Brown initiated what would become the most detailed investigation into hereditary sensory neuropathy ever attempted. His focus was the Data family. For the first time, researchers had access to modern genetic sequencing tools, allowing them to move beyond symptom description toward molecular identification. Dr. Brown and his team began collecting blood samples from dozens of Data family members spanning multiple generations, ages, and progression levels. Each vial represented a snapshot of the same mutation at different stages of its expression. The laboratory's approach was systematic. Researchers cataloged patterns of sensory loss, deformity, and inheritance, pairing clinical observation with genetic material. Advanced biochemical assays began to reveal the cellular consequences of the defect. Under the microscope, nerve tissues displayed the same hallmark pathology: degeneration of sensory fibers and abnormal lipid accumulation. What had once been a family mystery was now a reproducible biological process. The partnership between the Data family and the Seelby Day lab formalized a new model. Patients and researchers working side by side. The family provided data, travel records, genealogies, and consistent follow-up visits. The scientists provided continuity documentation and the technology capable of decoding what earlier generations could only describe. The collaboration bridged a century of incomplete understanding. By 1990, the family decided to take control of their own destiny. That year, the Data Foundation Incorporated achieved nonprofit status in Pennsylvania. Its purpose was clear: to fund research into hereditary sensory neuropathy type I, what the scientific community had begun calling the Data Disease. The foundation structure was simple but effective. Family members served as officers, volunteers and fundraisers. They organized meetings, newsletters, and awareness events to connect affected relatives scattered across the United States. Every donation, whether from kin or stranger, was directed toward laboratory research. What had started as a rural family tragedy had become an organized scientific effort. The Data Foundation maintained direct communication with Dr. Brown's lab, providing a living database of family health updates. Each birth, diagnosis, or progression case became new data for analysis. Through this coordination, 6 generations of the Data lineage were now medically tracked, one of the longest continuous family studies in genetic medicine. Their actions changed the narrative. The Datas were no longer passive subjects in a medical archive. They had become architects of their own investigation, transforming endurance into strategy. The family that once waited for science to name their condition now financed the search for its cure. 6 generations affected. One foundation formed. The family would not wait for science to find them. They would fund science themselves. The search for the molecular cause of the Deater condition ended at a single gene. After years of tracing inheritance patterns and collecting blood samples, scientists isolated the defect on chromosome 9 within a gene known as SPTLC1. This gene encodes the enzyme serine palmitoyltransferase, a critical component in the production of sphingolipids, fat-like molecules that insulate and protect nerve cells. In healthy cells, the enzyme performs a simple precise task. It combines L-serine with another molecule palmitoyl-CoA to produce a compound used in building the outer layers of nerve membranes. These sphingolipids keep electrical signals intact, ensuring that touch, temperature, and pain can be transmitted safely through the body. For most people, this process runs perfectly from birth to death. In the Deater family, it did not. The SPTLC1 mutation altered the enzyme shape just enough to confuse its choice of building blocks. Instead of using L-serine, the defective enzyme began accepting L-alanine or glycine, similar molecules but chemically wrong for the task. The result was catastrophic. Each substitution created a malformed product called 1-deoxysphingolipid, a compound toxic to nerve cells. These 1-deoxysphingolipids cannot be broken down by the body's metabolic systems. They accumulate inside nerve cells slowly, silently over years. At first, the damage is microscopic. Membranes stiffen, electrical signals distort, small fibers weaken. But as the buildup continues, the toxicity spreads through the peripheral nervous system, destroying the ability to feel heat, cold, pain, or pressure. This mechanism also explained the condition's cruel timing. The mutation does not cause immediate harm at birth. Instead, it programs each cell to produce its own poison gradually. By adolescence, enough toxin has built up to disrupt nerve communication. By adulthood, the damage is irreversible. The long delay between inheritance and manifestation was not random. It was chemistry on a slow clock. When researchers at Massachusetts General Hospital published their findings, they described the Deater lineage as a genetic model for toxic metabolic neuropathy. The discovery revealed that the condition was not merely a failure of the nerves to transmit signals. It was an active biochemical process of self-destruction. Every nerve cell in an affected individual was functioning as its own slow poison factory. This discovery marked a turning point in understanding hereditary sensory neuropathies. The mutation was identified, the biochemical pathway was mapped, and the molecular culprit was visible at last. Yet, there was still no cure. Knowing the gene did not reverse its effect, it only made the mechanism undeniable. The Deater family had lived through 6 generations of its consequences. Now, science could finally name the enemy, an invisible error, forcing the body to betray itself. The mutation was not destroying their nerves directly. It was forcing their own cells to produce poison. By the late 1990s, the Deater family name had entered the language of medicine itself. What began as a surname in rural Pennsylvania became a formal term in neurology textbooks and research journals. Clinicians now referred to hereditary sensory neuropathy type 1 HSN1 caused by the SPTLC1 mutation as Deater disease. The label was not symbolic. It was functional. The Deater lineage had provided the most complete genetic and clinical record of the condition in existence. 6 generations had been documented, examined, and tested under consistent methodology. Their mutation became the reference standard for all subsequent research into hereditary neuropathies. In the same way that Huntington's and Parkinson's carried their discoverers' names, this one carried the family's. Medical literature began to cite the Deater kindred as a model for toxic neuropathy mechanisms. Researchers used their DNA samples to explore how disrupted lipid metabolism could damage nerve cells over decades. The mutation's predictability made it ideal for controlled study, allowing scientists to map the gradual biochemical decay of sensory nerves in precise sequence. Then came the broader revelation. The same 1-deoxysphingolipids that accumulated in Deater family nerve cells were also elevated in diabetic neuropathy and chemotherapy-induced nerve damage. What began as a rare genetic anomaly now provided insight into millions of unrelated cases. The data mutation had inadvertently exposed a universal weakness in human neurochemistry, the susceptibility of nerves to toxic lipid buildup. Pharmaceutical researchers began testing whether reducing these lipids could protect nerves from damage in other diseases. Studies of the data samples guided drug design and dosage experiments for therapies aimed at cancer patients and diabetics. Their genetic signature became a tool for prevention far beyond hereditary disorders. For the scientific community, Deater disease represented the intersection of tragedy and progress. It demonstrated how one family's genetic error could illuminate entire branches of neurology. For the family itself, it was a strange transformation. The same name once whispered in hospital corridors was now cited in lectures, journals, and laboratories around the world. Their blood had been the medium through which science learned how nerves die and how they might be protected. The Data Foundation continued to fund research, linking families across continents who shared similar mutations. Their medical legacy expanded beyond their own ancestry, touching those who would never know their name, but would benefit from their data. A rural family once defined by numbness had given the world its clearest picture of how nerve degeneration begins. The condition that had taken their sensation had given science new understanding of how to preserve it. Their curse became their legacy. The family name that carried the mutation now carries hope for millions. In the early 2010s, researchers launched a clinical experiment that would redefine the data story. It was called the SENSE trial, short for serine supplementation in neuropathy. Its goal was simple in theory, radical in execution. Correct the metabolic imbalance by overwhelming it. The concept came directly from the genetic mechanism discovered years earlier. The SPTLC1 mutation caused the enzyme serine palmitoyltransferase to use the wrong building blocks L-alanine or glycine, producing toxic 1-deoxysphingolipids. The researchers proposed a counter-strategy. Supply so much of the correct substrate L-serine that the enzyme would be forced to use it instead. The plan was to flood the system with the right ingredient, thereby suppressing production of the toxic byproducts at their source. To test this hypothesis, the team designed a randomized double-blind placebo-controlled trial, the gold standard of clinical research. Participants were divided into groups, neither they nor the investigators knowing who received real treatment. The dosage was unprecedented. 400 mg of L-serine per kilogram of body weight per day mixed as a flavorless powder dissolved in liquid. Every dose was calculated to saturate the bloodstream with the proper substrate. A total of 29 patients enrolled. Nearly every known living individual with the data mutation participated. The trial included both symptomatic and pre-symptomatic carriers spanning generations. Each underwent baseline evaluations that included muscle MRI scans to objectively track nerve and tissue changes over time. Researchers documented strength, sensation, and biochemical markers before and after treatment. The logic was elegant in its simplicity. Instead of targeting symptoms or damaged tissue, the therapy aimed to correct the biochemical decision made at the molecular level by flooding cells with L-serine. The hope was that the defective enzyme would revert to normal function, lowering production of the toxic 1-deoxysphingolipids responsible for nerve damage. Over the following year, blood tests confirmed measurable reductions up to 60% decreases in the toxic lipids among treated participants. The therapy was well tolerated. Some reported mild gastrointestinal discomfort, but no serious adverse effects occurred even at the highest doses. For a condition with no previous treatment, this was the first measurable intervention that altered the underlying chemistry. The success of the SENSE trial did not erase the mutation, but it changed its meaning. The family that once defined hereditary loss of sensation now defined a therapeutic breakthrough. Their DNA, once a symbol of inevitability, had become the blueprint for intervention. The Data Foundation had helped fund it. The researchers had executed it. Together, they had turned passive inheritance into active prevention. For 120 years, the mutation dictated the terms. Now, science offered a counter-move. 12 months after the start of the SENSE trial, the results were undeniable. Plasma analysis revealed a 40 to 60% reduction in 1-deoxysphingolipids, the toxic compounds responsible for nerve destruction. For the first time in documented history, the biochemical signature of Deater disease had changed direction. Researchers at Massachusetts General Hospital and collaborating institutions analyzed every participant's data. The toxic lipids that once accumulated unchecked were now measurably declining. Each test tube of blood told the same story. The wrong molecules were losing ground. The treatment was working at the source, the enzyme itself. Clinical measurements confirmed what the chemistry showed. Using the Charcot-Marie-Tooth neuropathy score, investigators recorded measurable improvements in sensory function and muscle strength across nearly all participants. The lower legs, where degeneration usually began, showed greater stability. Grip strength in the hands improved. Several individuals who had been steadily declining for years, plateaued or even regained partial movement. Nerve conduction studies provided the most objective evidence. Electrical signals, once slowed by damaged fibers, began traveling faster. Researchers found a direct correlation. The greater the reduction in toxic lipids, the stronger the nerve response. The body was not regenerating lost nerves, but it was regaining efficiency in those that remained intact. The therapy's limitations were clear, but crucial. L-serine supplementation stabilized progression. It did not reverse past injury. The nerve fibers already destroyed could not be restored. But those still viable were being protected. For a disease defined by inevitability, stability itself was a breakthrough. Adherence mattered. Participants who missed doses saw lipid levels rise again, confirming that the treatment worked only while sustained. The body continued producing the enzyme daily and only constant supplementation could keep the chemical balance in check. It was not a cure, it was containment. Mild gastrointestinal discomfort was reported in a few participants, particularly at higher doses. Adjusting intake resolved it. No serious adverse reactions occurred. Compared with the risk of uncontrolled progression, the side effects were negligible. Beyond laboratory data, the human results were visible. Family members described improvements in balance, fewer injuries, and reduced fatigue. Pain episodes lessened in both frequency and intensity. One participant described being able to walk unassisted again after years of decline. For the first time in more than a century, the data lineage could take an active role in slowing its own inheritance. What had once been an unstoppable molecular process was now a managed condition. Generations of inevitability had given way to intervention. The toxic chemistry that shaped the family's history could finally be restrained, measurable, predictable, and controllable. The mutation could not be erased, but it could be starved. 140 years after Alvin W. Data's birth, his family's story has reached a turning point. 6 generations have now been clinically documented. Every birth, symptom, and genetic test recorded in medical archives. What began as an invisible inheritance has become one of the most studied hereditary conditions in the world. Today, L-serine supplementation stands as the standard management for hereditary sensory neuropathy type 1 caused by the SPTLC1 mutation. Family members begin therapy in adolescence before irreversible nerve destruction occurs. The treatment does not cure, but it prevents toxic 1-deoxysphingolipids from accumulating to damaging levels. What once began with numbness now begins with prevention. The Data Foundation continues to fund new research, expanding from supplementation into gene therapy, the effort to silence the mutant gene itself. Scientists are using 2 approaches. CRISPR-Cas9 gene editing and antisense oligonucleotides, both designed to suppress or correct the defective SPTLC1 transcript before it produces the harmful enzyme. Laboratory models in cultured nerve cells show promise. Animal trials demonstrate that silencing the mutant gene reduces toxic lipid production almost completely. Human clinical trials are now in planning stages. Ethics boards and federal agencies are reviewing proposals to deliver these therapies safely to living carriers. The goal is not to manage symptoms, but to prevent them entirely, to make inheritance biologically meaningless. Parallel to this, pediatric L-serine trials are underway. These studies test whether early supplementation before symptom onset can maintain healthy nerve development indefinitely. The hope is to delay or eliminate the disease's appearance in children who carry the mutation. For the first time, a generation may grow up without ever feeling the first sign of loss. Within the Deater family, these advancements have changed what it means to make choices. Descendants now undergo genetic testing before starting families. Some choose early treatment for at-risk children. Others participate in gene therapy registries. The decisions are deeply personal, but unlike their ancestors, they are no longer decisions made in ignorance. They are made with knowledge, intervention, and hope. What was once called Deater disease may soon become a historical term. A record of a condition that existed before human genetics learned to correct its own errors. The same lineage that defined the disorder is now helping define its cure. In Bear Creek, a young Deater descendant, the same one from the beginning of this story, remains on daily L-serine therapy. Her symptoms have stabilized. She represents both the past and the future. The latest entry in a ledger that may soon close. Alvin Deater died in 1952, never knowing his name would become a disease. His descendants may live to see that disease become history. The mutation wrote itself into their blood. Science is writing them out.